Question 15. Of the line tangent to x cubed minus x times y squared plus y equals 12 at the point 2, 4. So anytime we're talking about the slope of a line again, we're looking for the derivative at that point. So we want to find the derivative of x cubed minus xy squared plus y equals 12 at the point 2, 4. Now, so y dx at the point 2, 4. Now, because this function that we have is in terms of both x and y, it's going to require that we do implicit differentiation. Implicit differentiation with respect to x. So if we have an x term, like our first term, it's easy to do the derivative. We just do it as normal. The derivative of x cubed would be 3x squared. But this next term is going to be a little more complicated because it's x times y squared, which means we're going to need a product rule. So product rules, we'll do a foggy gothy. So the first function, which is x, times the derivative of the second function is going to be 2y, and since this needs to be with respect to x, we have to have a dy dx multiplied on the backside. Plus our second function, which is going to be y squared, times the derivative of our first. The derivative of the first function is just 1, so we can close it off there. And notice I used parentheses there because we're subtracting that entire product. Next derivative, we have plus y, so we take the derivative of y, it's just 1 dy dx. And then finally the derivative of the 12 is equal to 0. Implicit differentiation involves taking the derivative of the entire function, so don't forget that that constant needs to have the derivative taken as well. Alright, the next step is to isolate the dy dx, get the dy dx's on the same side, get everything else to the other side. So when we do that, we're going to get dy dx, and if I leave that on the left side, it's going to leave me with 1 minus 2xy, and that's going to be equal to negative 3x squared plus y squared. Now to solve for dy dx, all we have to do is divide out by the 1 minus 2xy. So dy dx, our derivative, is equal to negative 3x squared plus y squared, all over 1 minus 2xy. But to get the slope of the line tangent to that function, we've got to plug in 2 for x and 4 for y. When we do that, our derivative is equal to negative 3 times 2 squared plus 4 squared, all over 1 minus 2 times 2 times 4. In the numerator, that then leaves us with, let's see, positive 4. In the denominator, we'll get a negative 15, just leaves us with a negative 4/15 as our final answer.